from the slide I want you to look over because the quiz Friday will have some of this vocabulary. On Monday, I showed you the flip book example. Okay, that's how your animation is going to work. Each time you turn a page, something slightly changes. And you're going to use variables to help you out. And then I'll talk about if statements. So arithmetic is just like math class. You have plus, minus, times, and divide, and it helps save you some calculations that you don't have to do in your head. Instead, make the computer do it. This thing is called modulus. It's the remainder function. That's useful. You'll see it later on in the semester, not right now. Okay? All these things, when we string them together, they're called expressions, a mathematical expression. A coding statement is something that does something. This one just has a value, like 3 plus 5 evaluates to 8. This expression, 5 plus 3 evaluates to 8. And then down here, you have more examples. You can string them together and see it also gives you values. And you can try this out. But it's just like simple math, but we just read it in one line. 6 divided by 2 times the quantity 1 plus 2. It follows order of operations. Nothing new there. But what is new is thinking about, okay, I have expressions like I have here in the second argument, in the fourth argument. It can save you some calculating, right? Since they evaluate to numbers, they work just like numbers. So you can think, okay, where's this, or how high or wide is this ellipse going to be? Is it wider than it is tall, or taller than it is wide? We'll think for a couple seconds. Probably, right? It goes x, y, and I think width, then height. I may be wrong about this. So it should be wider than it is tall. And you can check your work by copying, pasting this line of code into a code pen. You can even put this particular line into GameLab and see and check your work. Okay, so why is that useful? Well, you can make use of symmetry to get some neat patterns to appear in your first animation. Notice it's an ellipse, right? I don't have to mouse over here and then kind of estimate how many ever pixels it is over. I know I want it to be 75 pixels away from like a center. Your center line is 150 here. And then you go 75 left, and then you 75 right. And you'll see this a lot. In translating that to code, well, left is minus, adding is plus. Okay? Do that once. You can do that a bunch of times. And save yourself some work. Computers are really good at doing math. So this is the stuff I previewed on Monday's lecture, and now we just go into more detail. So if you want to use variables, it's not just x equals 5. You need a little bit more than that. To tell the computer it exists, you first declare it, and that's a vocabulary word. Okay? Variables, these can hold different things, right? And Mr. Simon loves this analogy. He calls it a mailbox, right? Mailbox is there. Nothing's inside the mailbox yet, but it's waiting to be filled with something. Value, letter, right? That's why you need this keyword, var. I think we're eventually changing that to let. It works the same way, let and num. Okay? Or you can use, so this is more modern JavaScript. Let and num. So num is the name of your variable. Same with this one. Okay, let or var. There's a slight difference. This is the name of your variable. And there's some formatting to this. Names of these can't have spaces or unusual characters. Like you can't begin this thing with a %sign. You can't do like num space property, right? It's gonna think, okay, wait. This thing, it's white spaces are special, right? It's gonna think it's two separate things, and your computer is gonna complain. That's something about the declaring step. Okay, once you have it declared, like I did over here, now you got to store it. Now this stuff is exactly like in math, right? Num equals 5. And if I ask the computer what's stored in num, it equates that with 5. You give it an initial value. You give it some meaning, okay? And often you'll do both the declaration and initialization steps all at once and just type var num equals 5, right? 2 steps in one. So far so good? Not so bad? Once you have some variables declared, you can use these variables in place of numbers, right? And now here's value 1, so 17 will go here. Value 2, you'll take away 13 from 50, and they work just like numbers. some more things about the equal sign, okay? The equal sign is very special in computer programming. It's called the assignment operator. And the left-hand side is different than the right-hand side. So notice, in math class, it's perfectly legal to write like 5 equals num, okay? But the computer programming, in code, this thing you definitely can't do. Num is the mailbox, 5 is the value. You can't put an empty mailbox into like a letter, if I'm following that analogy correctly. Num must come first, then it must equal 5. So this is definitely going to be on your quiz, right? I'm going to say which one's the correct way to like initialize a variable, and right now this is totally off, right? You're trying to, right? The num is ready to receive, 5 is not. 5 is already set. 5 is 5. You can't change that. You can change num, okay? And the assignment operator means the equal sign. So notice we can put variables into arguments, right, wherever we see expressions. But here, notice we can't declare and initialize and all use that in here, right? You got to separate it out. This is a declare and initialize step, and then you use it. So the third thing is, okay, once you have your variables, it exists, it has a value, you got to use it somewhere. You can't combine all that into one. You got to separate it. Technically, that should be var. I don't think I could change that. The green is kind of hard to see. We're now giving you more examples of the updating step. This thing looks weird in math, right? X equals x plus 1. You solve for x, you get 0 equals 1, and then you say no solution. Because the left-hand side is different than the right-hand side, what you're doing here is actually updating x. So if x starts at 3, you add 1 to it. What's x's value now? Yeah, it's 4. And this could be repeated again and again. So what happens is the right side is evaluated first. You did 3 plus 1, and then you store it into x again. So it's now updated. And if it repeats, well, then you just keep growing by 1. 4 plus 1, 5 plus 1, 6, so on and so forth. And that's how we got an animation to occur. That's how it moved across the screen. And then look over these. I'm going to skip over these. It makes use of some nice symmetry. Like I'm sure you had a case where you had to like shift all your shapes or your animals like over a couple pixels, and you have to change a bunch of numbers. Well, what's nice is you can make variables and just change it once, like I did up here as I switch back and forth. Offset's values changed, and wherever it saw offset, it applied that change without you having to go in and type it all out. So it's kind of neat. There's a quiz question. The next slide has an answer. And I think I go over it in one of these videos from fall of 2019. There's another version of it, and there's another one, okay? That's variables. But I'm just going to pause it there so you can digest that. If statements coming up after this, okay?